Look, we're all super excited about the AI revolution, right? But it turns out it comes with a hidden cost. You could call it an invisible tax that's already starting to show up on the price tag of your next phone or laptop. Today, we're going to break down exactly how the AI boom is creating a massive global memory shortage and what that actually means for your wallet.
So why is your next laptop going to be so expensive? It seems like a simple question, right? But the answer is, well, it's incredibly complex. If you've been even thinking about upgrading your PC, your phone, really any piece of tech, you are about to walk straight into a perfect storm of supply, demand, and frankly, brutal corporate strategy that is sending prices straight through the roof.
Yeah, the tech world has already slapped a catchy, kind of scary name on it, Ramageddon. But here's the thing you need to understand. This is not like the last chip shortage we saw during the pandemic. This isn't about supply chain hiccups. No, this is a fundamental, ground-up shift in the entire semiconductor industry, and it's all being driven by one single, incredibly powerful force.
And believe me, this isn't just a tiny price bump we're talking about. We are seeing price increases for the core memory components, the DRAM and NAND flash and everything, of between 200 and 400%. No, that is not a typo. These are the absolute essential building blocks inside literally every digital device you own.
So, what's behind all this? Well, it all comes down to one thing: AI's absolutely insatiable hunger for memory. The demand coming from artificial intelligence infrastructure is just so massive, it's completely warping the market and basically starving the consumer electronics world of the components it needs to survive.
Okay, to really get what's happening, we need to talk about something called the memory wall. You see, for years, processors just kept getting faster and faster. But eventually, they got so fast that the memory couldn't feed them data quickly enough. It created this huge bottleneck. For most things we did, we could live with it. But for AI, no way.
And this is why AI changes the game entirely. Training a large language model isn't like running a spreadsheet or even a high-end video game. It means moving petabytes of data from memory to the processor and back again billions of times every single second. The standard memory we've been using for decades, it just completely broke under that kind of strain.
Okay, if you want a number that'll really blow your mind, think about this. OpenAI's next big project, an AI supercomputer they're calling Stargate. That single project is expected to gobble up as much as 40% of the entire planet's output of DRAM. One single project, 40% of the world's supply. It's just staggering.
So, the old way was completely broken. Engineers needed something totally revolutionary. And what they came up with, well, it's brilliant, but also borderline insane. They decided that if you can't go wider, you have to go up. They started building what you can only describe as an impossible memory tower. This crazy new solution is called high bandwidth memory, or HBM for short. Now here's the key difference. Instead of sticking memory chips on the motherboard, which is actually pretty far away from the processor, HBM stacks them in a tower right next to the processor. This makes the path the data has to travel incredibly short, which makes it insanely fast, perfect for the kind of massive parallel work AI needs to do.
And when I say faster, I mean a jaw-dropping leap in performance. Look at this. With this 3D stacked memory, we're talking over a terabyte per second of bandwidth, more than 10,000 connections. It just obliterates everything else. This, right here, is the breakthrough that makes modern AI physically possible.
But let's go back to that quote, borderline insane. Why? Because actually building these little memory towers is one of the most difficult, most precise manufacturing challenges humanity has ever attempted. Let me try to break down this nightmare manufacturing process for you. First, you have to perfectly stack up to 12 paper-thin, incredibly delicate memory chips. Then you have to drill thousands of microscopic tunnels straight down through every single layer. And finally, you connect them all with these tiny solder balls, and each one is smaller than a single human red blood cell. The precision is it's hard to even comprehend. And as you can imagine, this process is an absolute nightmare for yields. Because if even one thing goes wrong on one layer, the entire stack, all 12 chips, gets tossed in the garbage. Right now, almost 1 out of every 3 of these finished HBM stacks is scrapped before it even leaves the factory. This incredible difficulty is what's creating this massive supply crunch.
So you've got this amazing, essential new tech that's incredibly hard to make. What happens next? A battlefield. And on that battlefield, one company, Nvidia, is playing a game of chess while it seems like everyone else is playing checkers. They're executing a ruthless strategy to just control the entire supply chain.
There's actually a name for what they're doing: strategic capacity capture. And this isn't just about buying up the available chips. No, this is a deliberate, long-term plan to lock down the manufacturing factories themselves, basically denying resources to any competitor on an industrial scale.
So how are they pulling this off? Simple. Money. A lot of money. Nvidia has put up a mind-boggling $45.8 billion in purchase obligations and prepayments to the companies that make this memory. This isn't just placing an order, it's practically financing their entire operation.
And with that kind of cash, they can basically dictate the terms. They're using massive prepayments to lock memory makers into exclusive long-term deals, booking out production capacity all the way through 2026. They're even paying for new factory equipment for their suppliers, just to make sure any new capacity serves them first. This next quote just says it all, really. It perfectly captures their mindset. It's not about profit optimization. It's about building a moat around their castle that no one else can cross. They're willing to literally burn billions of dollars on inventory they might not even use, just to keep that precious factory capacity out of a competitor's hands. Okay, so there's this massive corporate war happening over these tiny, impossible-to-make chips. Why should you care? Because every single one of those HBM chips made for an Nvidia AI accelerator is made with the same silicon in the same factories using the same equipment that was supposed to go into making the memory for your next smartphone or laptop. And don't just take my word for it. The people who actually build our gadgets are starting to panic. The chief operating officer of Dell, one of the biggest PC makers on the planet, said his company has never witnessed costs escalating at the current pace. When a giant like Dell sounds that kind of alarm, you know things are serious.
And this isn't just some executive getting nervous. The hard data is telling the exact same story. The top analyst firm Gartner is now forecasting a major contraction in the market. PC shipments are expected to drop by over 10% and smartphones by over 8%. Why? Because higher prices are forcing all of us to delay upgrading our stuff. But here's the real gut punch, the prediction that's going to affect a lot of people. Gartner is saying that these soaring memory costs are making cheap, budget PCs financially impossible to build. They are projecting that the entire sub-$500 PC market will simply vanish by 2028. The affordable, entry-level computer could literally become a thing of the past.
So yeah, the AI revolution is here. It's exciting. It's bringing incredible new things. But nothing is free. The resources it needs are creating this fierce, high-stakes competition that the AI giants are winning. And the cost? Well, it's being passed down to all of us as the invisible tax of this new AI economy. And it really makes you wonder, who's going to be left footing the bill next?